Hello and welcome to our final topic for this module, where we will look at some applications of regression analysis. So we talked about regression analysis in the last topic, and basically what we found was that regression models or regression equations could be calculated to fit certain data sets. And we looked at specifically calculating either a linear regression model if the data was sort of increasing or decreasing at a constant rate, and we also looked at calculating exponential regression models if our data sort of leveled out, like decreased exponentially or increased exponentially with sort of a leveling out at the beginning or the end. And we said we could judge the quality of the model that we calculated and the accuracy of the predictions it would make using the correlation coefficient. So if we looked at the value of r squared, we could figure out how good of a model we would have. But the whole point of calculating the regression model was so that we could use it to make predictions. And that's the piece that we're going to add on today. Okay, we're going to look at how to use our models to make predictions. So once we have our regression model, the appropriate regression model calculated in Desmos, we're going to use it to make predictions. And usually what will happen is our model contains two variables. It's going to have an x and a y in it, and we're going to be given one of the variables, and we're going to have to predict the value of the other. So if we want to predict an x value. Okay, if we want to predict an x value, it's because an x value is going to be given to us. If we're going to predict an x value, it's because the y value that corresponds with it's going to be given to us. So we want to type that given y value into a separate line, and when you do that, typing that y value in is going to create a horizontal line on the graph. And we're going to try to find the point where that horizontal line intersects the graph for our regression model. And the intersection is going to show our prediction. And then the same thing will happen if we're working in reverse. If we want to predict a y value, it's because an x value is going to be given to us. So we're going to type that given x value into a separate line. Typing that x value is going to create a vertical line in our graph. And again, we want to find the point where that vertical line intersects, can't spell and talk at the same time, intersects our regression model, and the intersection is going to show the prediction. Okay, so here is an example. It says that the heights and shoe sizes of a dozen women have been collected and organized into the table. So the first thing we're going to do is calculate a regression model for the data. So remember, we're going to go into Desmos, and we would normally be hitting the plus sign to add our table, but I've actually already typed this one in there. So you add your table and you type all the data in. I was just trying to get a head start on you here. And then into another line, we're going to calculate both the linear and the exponential and decide which one's going to be better. So the linear is going to be y1 and then tilde mx1, and then we need a plus b. And so we have an r squared at 0.75, it's okay. And then we have, let's see, y1, and then again a tilde, and this one's going to be a parentheses b, close the parentheses, and then raise it to the x1 power. And this one, r squared, is 0.74. So 0.75 is just a smidge better, which means we're going to go with the linear model in this case. Okay, so again, r squared for exponential is about 74%. R squared for the linear is 75%. That is better. That is closer to 100%. So we're going to go with the linear model here. So our linear regression model. First, let's see. Our linear regression model is going to be of the form y equals mx plus b, and in this particular case, we're given that m is going to be approximately 0.5055 that decimal is going to keep going, but we don't need all of it. And that b is going to be approximately negative 25.4, oops, 0.0441. So we're going to put those together and say that y is going to be, let's go ahead and round this to 0.51x minus 25.04. So it doesn't specify where to round in this one. Generally, the hundredths place is going to be fine. If you wanted to keep more on the decimal, they're also fine. Okay, so there's our model. Now we're going to use the model to make some predictions. So this is the point of creating the model. So if you look at the next part here, it says predict the shoe size for a woman who's 72 inches tall. Well, in our data for the dozen women, we don't have anyone that's 72 inches tall, so I can't use the data to try to guess what the shoe size would be. So this is where the model is going to be helpful. Even though the data stops, the model continues. So I forgot here, but I'm going to hit my zoom fit button so I can actually see. You want to work with me here? There we go. Use my zoom fit button so I can actually see my data and I can see my regression model in there, and then it's pretty closely fitting that data. Now, in the next part here, when it says predict the shoe size, we are looking for one of the variables, and it says the woman is 75 inches tall. So let me go back here. The heights, these are what we put in the x column, and the shoe sizes, these are what we put in the y column. So when it says predict the shoe size, we're really looking for a y value. And when it says the woman is 72 inches tall, that's really telling us that the x value was 72. So since I know x equals 72, I'm going to go into a separate line here in Desmos, a separate line, and then I'm going to type in that value that I know. I'm going to type in x equals 72, and that put a vertical line in my picture. Now if I find the intersection of my vertical line and my graph, I can see the prediction. That intersection at 72 and 11.353 says that when the height is 72, the shoe size is likely going to be about 11.353. Now, obviously, that's not a shoe size, so we're going to round and say about, and I don't know, 11 or 11.5 would probably be an appropriate shoe size. Okay, so that is the predicted y value when the x value that was given to us was 72. All right, so now we're going to go in reverse. The next one says predict the height this time. So predict the height means we're looking for an x value when a woman wears a size 9 shoe. So that means that the y value, the shoe size, is 9. So let me go back into Desmos. Let me get rid of my vertical line. And I'm going to type in, again, a separate line. I'm going to put in the y value this time because that's the one I know. So y equals 9 goes in. That creates a horizontal line, the green one on my graph. And I want to find the point where that line meets my regression model. And now that intersection is showing me what I'm looking for. So it says 67.345, comma 9. Again, this is an x and a y, so when my y value is 9, my predicted x value is 67.345. That is telling me that the woman who wears a size 9 shoe is probably about 67 inches tall. Okay, so let's say about 67 inches tall. And that would be 5'7" approximately. Okay, so there it is, making predictions. All we're going to do after we've calculated the regression is type into a separate line the value that we're given, and the intersection of the line that it creates and our regression model is going to show us our prediction. Okay, let's try this all one more time. I think I have one more example to do here. And this time we have data that represents the number of goods in billions exported from the United States, and it says let X be the number of years after 1998, and that's important to this one. If X is the number of years after 1998, then when we type in our X values, I don't want to actually type in 1998. 1998 is 0 years after 1998. 2001 would be 3 years after. 4 years here, 5, 6, 7, 8, and 9. So we have to be really careful reading the directions. Because it says let x be the number of years after 1998, that means we're not going to type those years in. We're going to be typing in how many years after 1998 we're looking at. So our x values will be the 0, 3, 4, 5, 6, 7, 8, 9. And then it says the y values are the number of goods exported in billions. Okay, so we got to enter this data in. And I'm going to just delete everything and start over. Okay, so I'm going to put my table in. 0, 3, 4, 5, 6. This is why I tried to get a head start last time. I'm sure you don't want to sit here and watch me input data into a table. My apologies, but I couldn't put both in. Okay, 231.1. And what this means is this data, this was exported goods in billions. So in 1998, there was 231.1 billion goods exported from the United States. Okay, that's what this data is saying. All right, and then we go down to 201.3. And then we're going to go to 151.4. 147.9, and be really careful because one digit off is going to make your data different from what it should be. 127.4, 121.5, and lastly 118.7. And let me zoom fit that so we can see. It looks like we have data that is decreasing, and I can't tell if it's going to be linear or exponential, so let me put both models in. Let's see, y1, let's go with the linear first, tilde, m, x1, and then plus b. And it's a pretty strong correlation there, 90%. Let's go with the exponential, y1 tilde a parentheses b, oops, b, and then raise that to the x1 power, and r squared is 93% there. So 0.9007 is pretty strong, but 0.9304 is stronger. So this time we're going to go with the exponential. And the exponential model is supposed to be in y equals a times b to the x form. And it tells us that a is going to be 232.51. And it tells us that b, I'm going to round this one, is going to be approximately 0.9199. 9199. So I'm going to put those together and say my model is y equals 232.51 times 0.92 to the xth power. So that is my model. Okay, and now I'm going to try to use it to make some predictions. Oh, well, first it says did you choose a linear, exponential, and why? So we chose the exponential. And I'm just going to box that in here. Why did we choose the exponential? Well, the linear correlation was 0.9007. Just, I took it away. Yep, 0.9007, where the exponential r squared was 0.9304. And again, that is a stronger correlation. Stronger correlation. So the model would make better predictions. Better, more accurate, more reliable predictions from the model. Okay. Now that we know we're going to get better predictions, let's make some. Okay, so it says to predict the number of exported goods in 2013. So predict the number of exported goods. Again, these are exported goods. These are y values here. So if I want to predict the number of exported goods, then I am looking for a y value. And then in 2013 means we're how many years after 1998? Well, that is 15 years after 1998. So x equals 15. So that's because, again, 2013 is 15 years after 1998. Okay, so if I want to predict a y value when x equals 15, then I'm going to put x equals 15 into Desmos here. So go to a separate line. Let's type in x equals 15 and look for the intersection with that vertical line and my regression model. And so I see an intersection at 15, 66.482. So this is my x value, this is my predicted y value. So we're looking at 66.482 billion goods. This is about 66.5 billion goods exported in 2013. Okay, and then last one, it says predict when. That means we're looking for the year this time. The number of exported goods will decrease to 50 billion. That means the y value, the billion goods exported there, is 50. So now we're going to go in to a separate line and type in what we know this time, which is y equals 50. And then we're going to look where... Oh, didn't get rid of that one. Alright, look where that horizontal line crosses our regression, intersects our regression model. And so we see an intersection at 18.413, 50. So again, this is the predicted x value when we knew the y value was 50. So this says in about 18 years. And that would be after 1998. So we're looking at 18 years after 1998 would be 2016. Okay, there it is. So the harder part's making sure you type in all the data correctly, calculate the regression model that most accurately reflects or represents the data, and then type your given value in to make a prediction for the unknown value. Okay, so you've got some practice problems to work on, a quiz coming up toward the end of the week, and then just, as always, reach out if you need some extra help. All right, guys, take care.